Now for the next example, the half-life of radium is 1600 years. In how much time will its 15 by 15 fraction disintegrate? Again, the formula is the same. All these formulas we have recovered from n is equal to n naught e to the power minus lambda t. Then this equation is reduced to different types of compositions, like time of decay is calculated by t is equal to capital T log n naught over n whole divided by log 2. We should try to bring log 2 in the numerator so that it can easily cancel off. Now, capital T half-life, that is given 1600. So for capital T, we have computed 1600, and n naught over n will be 16 over 1 divided by log 2 multiplied by 2. That is the half-life. So this is equal to 4 into 1600 log 2. Log 2 will cancel off, and we will get 6400 years. In the next example, a radioactive material remains 25% after 16 days. That is, after 16 days, it becomes 1 over 4. 25% means 25 over 100. Its half-life will be how much? The time of decay, that is T, that is again calculated from the general equation. As I have cleared earlier also, in most of the questions, we apply the equation n is equal to n naught e to the power minus lambda t, and this equation can be reduced to the different forms. So here we are using a form small t is equal to capital T log n naught over n divided by log 2. When we don't write base with a number, that is understood that it should be log n over n base 10. So in all these cases, we have to convert the log. If it is given in terms of e, it should be converted into base 10. So 16 is equal to t log 4 over 1 divided by log 2, and log 4 can be written as log 2 square, that is 2 log 2, and log 2 will cancel off, and it will become 2t. So 2t is equal to 16, and t is calculated as 8 days. Now in our next example, the half-life of radon is 3.8 days. 15 mg of radon after 38 days will reduce to how much? So again the amount is given, so we have to convert the radioactive equation in terms of amount, like n is equal to n naught e to the power minus lambda t. In terms of mass, it should be m is equal to m naught e to the power minus lambda t. And then this equation will be converted to different forms. So it is now m is equal to m naught 2 to the power t over t. Then we compute the values as given in the question, and after computing the values, the mass is reduced from 15 mg to 0.01465 mg. Now for the next example, a specimen of the radioactive material contains 10 to the power 6 radioactive nuclei. Its half-life is 20 seconds. Half-life means the time in which half of the sample disintegrate. How many nuclei will remain undecayed after 10 seconds? So first of all, the general equation is again applicable. This is another form of the general equation. So we write it as n is equal to n naught, and the number is being given to us. So 10 to the power 6 into 1 over 2 power 10 over 20, that is 1 over 2. We simplify by rationalizing the result. Root 2 can be taken as 1.41. So 10 to the power 6 is divided by 1.41. And the amount comes to be 7.09 into 10 to the power 5. Now we come to the next example. The half-life of a radioactive isotope is 5 years. When we speak half-life, in the first life, the amount reduces to half. So we find that in the first half-life, that is in 5 years, if the radioactive isotope, it has amount m naught or m, it will be reduced to half in 5 years. Its fraction, which will decay in 15 days, either convert 5 years into days or convert 15 days into years and then start solving the question. The units must be in sequence. Now again, our equation is n is equal to n naught e to the power minus lambda t, and from that we get n over n naught. So by taking the composition as n over n naught, we will take it as 1 over small t over 2t. Then the values are given to us. We will put up these values and we will find after the simplification 1 minus n over n naught, that is equal to 1 minus 1 over 8. So that will be taken as 7 over 8. So we find that if radioactive isotope has a half-life of 5 years, its fraction which will decay in 15 days will be, that is 1 minus 1 over 8. That is 7 over 8. Now we come towards an example, another one. A sample contains two substances. That is, in one sample, there are two substances. One is P, other is Q. Like for example, it can be radium and uranium, or it is radium and plutonium. That is, in just one sample, two substances are present. And each has mass 10 to the power minus 2 kilograms. So whether it is sample P or sample Q, the amount is 1 over 100 kilograms, that is 10 to the power minus 2 kilograms. The ratio of their atomic weights, 1 is to 2, and their half-lives are 4 seconds and 8 seconds respectively. The masses of P and Q that remain after 16 seconds will respectively be, so how much is that value, masses of P and Q after 16 seconds. So we have to again go through with the general equation, which is written as n is equal to n naught over 2 to the power n. And this can be taken in terms of mass because capital N is proportional to m and n naught is proportional to m naught. So we will write an equation, m is equal to m naught 2 to the power n. Now for P, we will find n is equal to 16 over 4 as it is given in the question. So n will become 4 and np, that is 10 to the power minus 2, that is it is given for P. So np, number of atoms in sample P, that is taken in terms of mass. 10 to the power minus 2 divided by 16, it is 6.25, 10 to the power minus 4 kilograms. And then for Q, we will calculate it the same way. Now we have got the values of NP as well as NQ. That is what our aim. So the answers will be 6.25, 10 to the power minus 4 kilograms. That is for P sample. And for Q sample, the amount will be 2.5, 10 to the power minus 3 kilograms, because the amount is given in kilograms.